one thing that might be interesting in the future would not also be to connect your database with other databases in other countries, but also with geodata, and to also to visualize the data on a map. And I think we are highly pleased to welcome an expert from Slovenia. We're highly pleased to welcome Gregor Završnik from GeoArch in Slovenia, who will give us a presentation on digital geospatial data, a tool for interpretation of our past. I think this is one of the most exciting tools in digital humanities, that we can visualize things also on maps. So, Gregor, I have to introduce him also. He's an international consultant on geospatial field, and he works in various projects with the national archives, with mapping agencies and digital preservation solution providers. He's also in various international expert groups. So I think we can be really proud to have you with us, and so the floor is yours.
Thank you very much for the kind introduction, and could I ask for the slide? Thank you. I would first thank the organizers for inviting me. It's a real honor to be here and to speak on this conference. And let's just begin. So I was already presented, so I will skip this slide. But let's go to today's menu. So first we will start with geodata. What is geospatial data and what are the use cases for that? Maybe you will learn something more than you already know about maps and how they are used. Then we will go to how modern exponential technologies, which is the topic of this conference, and geodata can be used together, and also to complement the heritage field of data research and use. And then we'll skip to a more general topic of what gives data its value, to develop the reasons why we offered the fourth topic, which is the e-archiving specifications, that actually answer a lot of questions about the connectivity of the archives and bringing the archival data on a unified way available to AIs, to machine-readable sources, and so on. So we all know that maps were used since the beginning of time. People wanted to put locations of their treasures, of water, of stuff. They used it in military campaigns because someone said everything happens somewhere. And this actually means that if we want to analyze things in our surroundings, we need to map them somehow. And today, with the rise of computers in the last 100 years, this has gone to a more profound level, where maps are not only used to see where things are, maybe measure something, but now we can use a lot of mathematical operations and get a lot of very distinctive information derived from geospatial maps. Like in this slide, you can see that we can map streets or infrastructure in space, and we can calculate, for instance, if we have a water pipe, if you close down the water pipe on such a location, who will be without water? And then you can just list this from a table and send the information to the people, give them a notice. So this is how very useful this is in today's cases. Now, to understand how this works, as comparing to ordinary maps on paper or maybe scanned into imagery, digital geospatial data actually needs to be something that we can compute on. So these are actually mathematically structured objects in form of coordinate pairs that create vector data sets, or image rasters that are also set in grids and can be calculated. And since we have these mathematically structured objects, we can then combine them with other digital records like tables or other records, and use this in a so-called geographical information system to derive new results, to analyze things. And you will see how amazing results we can get. So this is just an ordinary thing where you can click on a polygon and it shows you the information from the table in the back. This is a very simple visualization and use of GIS. But if we go to a geospatial analysis example, you see that on the left you have a diagram of the algorithm where a lot of data sets were used and then computed with their various operations to receive a totally new information. In this case, we have a suitability analysis for water conservation based on more than 20 parameters. And the map actually shows where the suitability of the location is better than worse. But this is not just for object in space, it's also for intangible data. Like, for instance, analysis of crime, analysis of population data growth, analysis of rates of divorces, of public opinions, of anything that can be actually mapped to a location and then visualized and gotten information from that. And this is not something that is new. This is something that has been used for a while. So in this case, you see a map that looks like a very contemporary GIS map, but actually it's a map of frequency of marriages in Croatia from the beginning of the 20th century. So this already shows us that the approach has been used before, but now with the machine learning and computer aided technologies, we can receive results faster and better. And as Zoltan mentioned previously, certain things would not be possible without the computational power of computers. Now, what other use cases are there available? First is transportation analysis. You can calculate the path from point A to point B, which is the fastest road. I believe that everybody here used Google Maps or Apple Maps to navigate to a location, and then this is a GIS operation actually. It calculates the best route according to the distances, to the traffic densities, and so on. Then we have change detection, which is a very historic use case, because we need a long timeline of data to analyze the differences between old maps and new maps, and we can see what happened, how the forest changed, the amount of forest, did it shrink, did it grow, maybe coastal areas or erosion from water actually shows us how the riverbeds changed. Or we can see how cities grew, and maybe then use other parameters to analyze why this happened and how certain parameters impacted that. Then we have a very powerful tool of suitability analysis, which you saw an example of before for the water conservation. This is where we actually use different parameters, and in this case you see that different colors actually mean the distance from the road and so how suitable this is. But this is also used, for instance, in archaeology. So if we want to find a location where there could be settlements, we could say, okay, let's say how far from the water they would be, and then we can combine with other elements like, okay, maybe there was a very good fertile land over there and so on. So we could actually get information from GIS analysis for historic purposes as well. And then, of course, in business intelligence and government intelligence, where we actually analyze things on maps according to certain locations, be it statistical regions, zip codes, or administrative regions, and so on. And all this is actually used to identify patterns, okay, of behavior or patterns of change, and this is also something that we need a long period of data for. So this is where the archives become very relevant in this story, because we have a long time series of data available, but not yet accessible. So this is something that goes further. So if we summarize about the geodata and GIS, we can say that visualization is the primary idea of why to use it. But also it can be used by automated mathematical algorithms to calculate new data to identify relationships between objects and people and relationships between certain events. And all in all, we analyze the data of the past and visualize it to make better decisions in the future. Now, how does this come together with the new exponential technologies? Well, GIS has been in the core of this for a long time. And this is an example slide where in the United States, in a city, they used artificial intelligence and machine learning to identify correlation patterns that influence car accidents. It was actually, they used more than 7 years of data, about 400,000 accidents, and on 500,000 of road segments, including more than 20 parameters. It's an endeavor that couldn't be possible without the machine approach. And they actually are now able to predict where the accidents will happen based on the weather, the commercials that are on the side of the road. Did our football team win or lose last week, and how this influences the feeling of people. And they can now make decisions on how to add new signalization, maybe change some roads to reduce these events. And this is not just used in traffic, it's also used in agriculture, in analysis of other patterns. It was used in the COVID response for epidemiology and so on. So artificial intelligence and geodata go hand in hand to produce new events. Now the second approach is crowdsourcing, that is used to actually generate new data from existing maps and so on. This is an example of an online tool that can be used for geocoding scanned maps from diagrams, from books, from any source that we have. Because as we saw, it's not just important to have an image of a map. You have to have it located in space and probably digitized to a mathematical structure so that it can be reused in a GIS analysis case. So that's why the accessibility of geospatial records is nice if we don't have to go to the reading room in the archive, but you can have it online. However, if it's in a standardized format that can be used in a GIS application, it gives even greater value. And this is what I aimed with the specifications. Now, crowdsourcing has some issues. Maybe people are not interested enough, or they produce a lot of errors. So these platforms can offer innovative solutions like gamification, because gamification actually motivates people to do something. So this is where you see the image of a very popular game from previous years, which is Pokemon. It was a geotagging case. But we could also make a game for people to actually analyze some records that we've scanned and get points for that, and then use that points in a game and so on, and gain a lot of traction with this. And this is how we could actually connect the archives with the schools, with the museums, and also with the gaming industry. So we could tag old locations and geotag maps by using this type of technology, and also teach children something, or people something in the meantime. Now, this idea came about when we were thinking how to bring context to old records using maps. In a discussion on an ongoing project with a friend of mine, Dr. Hrvoje Stančić from Zagreb. I guess many of you know him. What they did is they use a classical machine readable recognition of written text, handwritten text on the food rationing cards, detecting borders between elements using AI, let's say machine learning. And this is something that we saw yesterday. But the idea was, well, we also have a space that defines the street and the house number where this person lived. And they had information about how many chickens they had, what type of business they were in, marital status, a lot of socioeconomic data. So why wouldn't we use this in a map and maybe add it to this information? Just like Zoltan said previously, the next step is geocoding and how to do this. using modern exponential technologies. So our idea was to use old maps and gamification like Pokemon to actually find the same locations on Google Maps, but it's just an idea, just to give you a proof of concept. It's not been done yet. So, but if we look at the exponential technologies like AI and big data, they are very useful and they bring us a lot of possibilities, but there are challenges with data. And one of those challenges is that we need data with rapid accessibility, connecting different archives in a way that is accessible, findable, interoperable, and so on. It's also that AI needs an AI-ready data, which is not always same as machine-readable. So there are also specific formats that the data need to be formatted in for it to be used in geospatial AI applications. And this is what brings me to the more general topic. What brings value to data in the digital economy? And I'm referencing a very old saying by Sir Francis Bacon from the 17th century, knowledge is power. But is it really? Because this is what was true at that time, where a lot of people didn't know how to read, books were scarce, information was gossip or something. But today, we have an environment where we have abundance of data, of information. Everything can be found online, so knowledge is available to everyone. So the problem is the knowledge applied? Is the knowledge accessible? And are we connected? Because the connectivity of knowledge actually gives it more value. Just let us take an example. We have one GIS analysis that everybody can use every day, which is, I would like to take my car from point A to point B, and it's calculated. Okay, that's nice. What if your car is broken, or you cannot drive the car that day? Okay, maybe I will use a taxi, or a bus, or a train, or maybe I'll walk. So you would need to connect to different analysis then. It's similar to having a possibility to connect to different databases. It gives you more value and more information and more knowledge, actually, to combine data with itself. Now, the next thing that this conference is about the innovation on the new digital exponential technologies in the archives. And the innovation is actually not just supported by incentive, but it's supported by environments where ideas can connect. And this is where the role of archives should be, to become environments where ideas about the reuse of the data can connect, because the archives are connected. And I know that everybody knows that this is important. I'm just trying to show a use case. How internet actually brought up new ideas like email, so the old mails are now almost gone. Netflix, which means that the services where you rented a videotape are now gone. Facebook, where people can now have a new platform to connect to decide. And Bitcoin, or let's say cryptocurrencies, which wouldn't be available without internet, but are now restructuring our modern financial approach. And built on those platforms, we can see again, for instance, on Facebook, we had games where people connected, but on the other hand, we also had example of Cambridge Analytica, which was a disruptive force of use of Facebook that influenced democracy in UK and United States. And on the other hand, now we have how cryptocurrencies are evolving and giving us possibilities to change the paradigm of selling art, of connecting to insurance that is fair, financial systems that are more fair, and so on. And similarly, we can see how actually the power comes from the connectivity. The many people who use it in an, let's say, connected way, which connected for me means without limitations that stop you because you need to change different formats and so on. I know this is just an idea, but there's this law that's used in telecommunications where they say that the value of a network increases exponentially with the square with the number of connected units in the network. Because on a telephone, if you have a lot of people who have the telephone, it's useful. But if you only have a telephone that you can call 2 people, then it's not a useful thing. So in a similar way, the value of the archives will exponentially increase when they connect with each other and have all the data available. Okay? So these were the challenges. What answers do we have available? I've come to the preservation domain through the EARC project, which started analyzing how we could have unified standards for packaging, metadata, and storage and reuse of different types of digital records. And one of the fair approaches, which fair means findable, accessible, interoperable, and reusable, is interoperability. And this is where my work started on specifications for geospatial records, how we can interchange geospatial records. But first, let me introduce the e-archiving building block, where this is now a reality. The EARC project evolved and became a building block for the European data communication framework, so that all the nations can actually start working on the same platform using these building blocks like e-signature. So if I e-sign in one country, it's valid in the other. And the idea was to actually also create an e-archiving building block where we have unified standards for metadata, for preservation of different types of digital records that support openness and interoperability and can be legally suitable for nations and so on. And in this e-archiving building block, we are developing standards on how to package things, reusing existing standards, tools for that, and trainings for that. And my role is to develop the common information type specifications for geospatial data. There are also common information types for databases, for ERMS systems, and others will follow. But my work was on this CITS geospatial or content information type specification. So the whole idea was to use existing ISO standards and OpenGIS standards, which are actually standards for the geospatial domain, so that all the data is in a long-term preservation format that is accessible to everyone, and also to support machine-readable discovery and access by using of existing standards for geospatial metadata and the archival metadata. And on the right, you see an example of the package. It's a folder structure based on the e-archiving common information package. And the specification actually comes in form of validation criteria, like you see two examples in the bottom. First of all, let's say if there is no geospatial file in the package, it cannot be a geospatial format. So that's one of the criteria. And we add others, like it needs to have a defined coordinate system. It needs to be in a long-term preservation format, which can then be extended for the purposes of different organizations. Now, I only have a short time today, so I cannot go deeper into this. I will show you a possibility to learn more about it later on. But this is the answer on how to achieve this connectivity between archives on the level of geospatial data. But of course, if you use e-archiving for other types of records, you can also achieve the interoperability and accessibility for preservation and reuse. So if you want to learn more, we are actually just setting up a new portal for everybody who is interested in geospatial data preservation, which is going to be called geopreservationeu. And it's live now. Actually, I've worked hard with my development team to make it live today. So if you want to be informed about the news, our idea is to have information about the conferences, about the user groups, about the standards, about the events that are coming up. Go on this website, give me your email, and I will send you the articles that I wrote for this, which tells much more about this presentation than I could say right now. So this is the first thing that I wanted to say. The second thing is, if you want to see how geospatial data can be preserved using e-archiving specifications, we have a webinar on the 21st of October. It's an online webinar. You just Google e-archiving webinars and you will find this page on the right in blue. And then, if you know the DLM forum, in DLM forum, I'm actually head of the GeoForum user group, where we connect everybody who is interested in talking about geospatial preservation, talking about ideas, challenges, best practices, and so on. And we discuss how to approach these ideas on the e-archiving and elsewhere. And also you can access the e-archiving specifications on the dilsys.eu, which is the digital information lifecycle something. It's actually a standard body that takes care of these e-archiving specifications. Or if you just want to contact me, you send me an email to gregor.f@geoarch.si. Now, why that? Because where can we contribute? Where can we help you with your start or continuation of your path of geospatial data preservation? First of all, I organize trainings for online courses and live courses in the archives, where we teach the archivists about geospatial data, their specifics, how they should be preserved, which elements are important for the preservation of that data. And we also had courses for their producers so that they can now talk to each other and understand why preservation is important from the side of producers. The second thing we can do is we can help you implement standardized geodata-specific preservation workflows. So if you want to implement geodata preservation, there are certain steps in the ingest process that are specific to geodata. There are certain steps in the data management or dissemination that you need to be aware. And we can also help you with the implementation of geospatial tools in the archives for such validation and so on, and also for the preservation and dissemination. Because there sometimes is a need to transform data in a proper way using legit software for that. And we can also help you with the dissemination on web platforms where you can use data and make them available to others so that we can connect on a very standardized way. And this is, I think, yeah, how do I go back? Yeah. How do I go back to my conclusions? Okay, so basically, what I want to say is that, okay, thank you. Oh, so it looks like it goes away by itself. I'll just read it from my laptop. So basically the conclusions are that geospatial data provides context to most other data. It's a common denominator. Space is a common denominator. And we can see patterns, we can see how things connect and what relations they are in. Then the second thing is the value of data is in its accessibility, and the value of data repositories such as archives is in their ability to connect with others. Then the next thing is the innovation that we want to achieve is supported by environments where ideas can connect. And this also means that if the archives create a platform where we can exchange data and communications, we can bring life to new ideas, new innovations, and new business models that can actually make our data more valuable. And in the end, the e-archiving specifications and tools support the interoperability of geospatial, but not just geospatial, also other types of digital records that repositories can use to connect and support innovations. And this is all I wanted to say. Thank you.
Thank you very much for that highly impressive and interesting presentation. I think one of the sentences of today that I will memorize for a very long time is, anything happens somewhere. And I think after your presentation, I think any historical information is incomplete with the respective geodata. And geodata opens up a fundamentally new view and understanding of history, in my view. So it's so powerful. I think we all have only to get the awareness about that in the future. But if we think about our everyday life, how much geodata already affects our everyday life, so I think it's not far to the way of thinking how much historical information is affected by geodata. Thank you very much. We are quite in delay, but of course, questions are always possible. Nothing in the chat? Okay, if nobody has a question, one thing that interests me very, very much is we've heard today of the project of Coat of Arms that develops some kind of OCR for Coat of Arms. And what I've been asking myself for a longer time is there already some tool that automatically transform a map in JPEG format or TIFF format into a vectorized format that can be processed as geodata?
Yes, actually, what we saw today, be it from the medical scans, used similar tools like image classification in geodata types. And also there are tools that vectorize, that we use for vectorization of, it's different types of vectorization. You have fully automatic, semi-automatic, and so on. So in the geospatial domain, there's a lot of tools that could be used for this.
Thank you. Yeah, so Gregor is here afterwards, so if you have any further questions, you can ask him afterwards. So I don't think that you have to stress to your flight. Okay, great. Thank you very much.